Students, now since we have learnt about directed numbers, now we are going to learn about fractions, decimals and percentages. And I'm sure you are familiar with these fractions, decimals and percentages. You have learnt all these in our lower classes, and you should have you would be remembering that when the teacher introduces fractions, usually it's an apple cut in half. Then one half of the apple is shown to you, and they say this is 1 by 2. And if it is further cut into two equal pieces, the teacher says it is 1 by 4. So you can recall all that, and usually it's an apple, right? Now, coming to fractions here, we define fractions as a part of a whole. It's just an informal definition of fraction. Fraction is a part or a portion of a whole quantity. Now, let me take a circle and then divide this circle into some equal number of parts. Now I have divided this circle into 8 parts. So each portion is is denoted by 1 by 8. Now you can see that there are 8 parts of it. The circle has been divided into 1, 2, 3, 4, 5, 6, 7, 8. So the shaded portion represents 1 by 8. Now in case I shade 3 of them, say I shade 3 of them, this one, and one more, then you know that this is 3 upon 8, right? Okay. Now, it need not be a circle all the time. It can be a rectangle. It can be any shape. But remember, the portions have to be equal in size. Now, a fraction or a rational number, since you know that we refer to fractions, negative fractions, and positive fractions as rational numbers. If you take a rational number, say for example 5 by 11, this 5 is called the numerator and the 11 is called the denominator. Now 5 by 11 makes sense because a whole is divided into 11 equal parts and you are looking at 5 of them. You are considering 5 out of the 11 parts that the whole has been divided. But what do you think of 15 by 11, say? Now, when you are dividing something by 11 parts, how do you think you can get 15? Here it is, you can do the long division, 15 divided by 11, so 1, and you are left with 4 as the remainder. This 1 that you get as the quotient is the whole. So here it is 1 whole, and you have 4 out of 11. So how do I represent this? You have this 1 whole, 1 plus, and then you have another circle, the equal circle, and then you divide this into 11 equal parts. Okay, so you can consider that this has been divided into 11 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, one more. 11. So let us assume that these are all equal and you are going to take 4 out of them. So 1, 2, 3, 4. And all of this. So 1 whole plus another 4 out of 11. This is 4 out of 11. So together. So this makes up 15 by 11. And here the numerator is greater. The numerator is greater than the denominator. Now, if the numerator is greater than the denominator, it is known as improper fraction. We call that as an improper fraction. And sometimes in very few books, I've seen that this is mentioned as vulgar fractions. So what is a vulgar fraction or an improper fraction? The numerator is greater than the denominator. And what is this 1 4 by 11? It's a mixed number. It's called a mixed number because you have a whole number, an integer, and also a fraction, a proper fraction. 4 by 11 is a proper fraction. Now, you can try these changing some mixed numbers into improper fraction and again improper fraction to mixed numbers. Now, for example, I can consider 2 5 by 7. This is a mixed number. I want to convert it into an improper fraction. So 2 times 7, 14. 2 times 7 and then you add 5 and then divide by 7. So that will be 14 plus 5, 19 upon 7. So 2 5 by 7 is the same as 19 by 7. A mixed number written as an improper fraction. So multiply the whole number and the divisor and add the numerator, which is in fact the remainder that you get when you divide 19 by 7. Now what about if I have a negative mixed number, negative 4 1 by 3, then what do? You just don't look at the negative number for the moment. Just consider 4 1 by 3. You convert that to an improper fraction. So 4 times 3, 12. 12 plus 1, 13. So this is negative 13 upon 3. Alright. So you should not make this error that multiplying 3 into negative 4, which is negative 12 and then add 1. No. That negative it is only saying that the number is negative. But this process of converting it into an improper fraction is the same. So first convert it into an improper fraction and then you assign the sign minus. And same goes for converting it into a mixed number. Say for example you have negative 20 by 3 say. So just keep the negative sign, change this 20 by 3 into a mixed number. So 3 divides 26 times, you are left with the remainder 2. Negative 2, negative 6, 2/3. Negative 6 and 2/3. Okay, now let us see how to convert a fraction into a decimal. Okay, before that, okay, I'm starting again. Now, I want to see where this negative 2 by 3, where is it located on the number line? So when you have the number line, it is below 0, so it's to the left of 0. And you have negative 1, negative 2, negative 3, negative 4, negative 5 and negative 6. Now where is this negative 6 2 by 3? It lies between negative 6 and negative 7. So it is even less than negative 6. 2/3 less than negative 6. So it goes further to the left of negative 6 but before negative 7. So if this interval between negative 6 and negative 7 is divided into 3 equal parts, 2/3 here. So this position is your negative 6 and 2/3. So now let us take, we will try to find out the two integers, one immediately less than and one immediately greater than the given number. Say for example, if I say negative 5.3, no, let us take fractions for now. If I take negative 5 and 1/3 or 1/4 say. Now this will lie between negative 6 and negative 5. Now what about positive numbers? Say 10 and 5 by 7. This is greater than 10 but less than 11. So this will be between 10 and 11. So you should know the range, the two integers between which a fraction lies. That will help you in estimating your answers when you do calculations. Now moving on to decimals. Decimals is another representation of fractions. So if I have 17 by 100, so this is 17 by 100. This is written as 0.17. If I have 5 by 10, it is 0.5, 5/10th, 1700th. You read this as the 17 by 100, which is written as 0.17, is read as 1700th. Now let us take a decimal number, say 12.385. Now the decimal point separates the whole number and the fractional part. So 12 is the whole number and 385 is the fractional part. Fractional part of this number. Now, in the expanded form, it is 12. I'm just writing 12, the whole number, plus we are concentrating more on this decimal part. So this is 3 out of 10 plus 8 upon 100 plus 5 upon 1000, which together can be written as 12 plus 385 upon 1000. And this, in the decimal form, it is 12.385. So when the fraction has 10 or powers of 10, it can be very easily written as a decimal. Say 393 divided by 10. Here the denominator is 10. You can easily write it as 39.3. 39 and the 3 tenths. 39 and 3 tenths. This is 39 plus 3 by 10. So for you to understand the magnitude of that number, the quantity, right? Now if the denominator is not at 10 or powers of 10, then how do you write it as a decimal? How do you write it as a decimal? So for example, if I have 121 divided by 12 or say 8, how do I change it into a decimal? If you have your calculator, it will give you the answer in a minute. Otherwise, you'll have to do the long division. 121 divided by 8, the usual division. 8 ones. Now you have to see how many times 8 divides 41. 8 fives are 40, and again I get the remainder 1. Now how do I divide 1 by 8? It's not possible. I need to add a 0. So before adding the 0, I keep the decimal point besides that 15, the quotient, and add the 0. Now 8 divides 10 once, and I get the remainder 2. And I want to divide further. I want to see what are the other decimal numbers that I get, the digits that I get. So I add one more 0 here. You can see 121, the whole number, has no decimals, right? So it can be followed by zeros. So you are bringing down the 0 one by one. So that is the reason we are adding 0. 121, a whole number, has no decimal parts. So you can add any number of zeros after the decimal point because it has no value. So 5, say if you have 5, it is 5.0. You know that 5.000. Any number of decimals can be added at the end of the number. So now when I have 20, I divide 20 by 8 twice, 16, again remainder 0. I bring down the other 0, now it is 5, 40, and it stops. So now what is the decimal representation of 121 by 8? It is 15.125. Now after that, you get a remainder 0 and you are not going to continue your division. So this is a terminating decimal. 121 by 8, which has been expressed as 15.125, it is a terminating decimal. Now we'll take another example where you will get a pattern. Say for example, we'll take a small number, say 14 upon 6 or 14 upon 9. Okay. Now we will see what is the decimal representation of 14 upon 9. Again, do the long division and 14 point, you can add any number of zeros after the decimal point. Your divisor is 9. Now 5, the point is placed after the 1 and you're having you have brought down a 0. So 9 divides 50 how many times? 9 fives are 45. You subtract, bring down the next 0, again 5. Now what you see here, it continues. You continue to get 5 as the remainder. So you write this as 1.555, and how many 5s can you write? So it continues forever. So you can write this as 1.5 with the dot on top of the 5. This is called a recurring decimal. It repeats. Some books call it repeating decimal, or we call it recurring decimal. Now there are some interesting patterns when you practice all these, try to convert certain fractions into decimals. Say for example, if I take 1 by 9, it will be 0.111. If I take 2 by 9, it will be 0.2222. Now if I want to find what is 7 by 9, I just have to multiply 1 by 9 times 7, which is 0.111 etc. into 7, and you know that it's going to be 0.777. So there are several interesting patterns like this when you try to find out the decimal representation of certain fractions. Okay. Now, how to find out if a fraction is repeating or a terminating decimal without actually doing this long division? That is, you don't want to get the decimal, but you want to know, is it going to be a terminating decimal? Is it going to be a repeating decimal? You just want to know that. So without doing the long division, how do we find out? Just check the denominator. Say if I write 11, say 11 by 40, you see the denominator, get the prime factors of 40. We know how to get the prime factors of any number, any integer, right? So 40, I'm going to get the prime factors. So I can write 11, but first, before doing this prime factorization, see if the numerator and denominator are co-prime. Now what are co-prime numbers? Prime numbers that have just, no, not prime numbers, two numbers that have just 1 as the common factor. So here 11 and 40, you cannot simplify it any further. So because 1 is the only common factor between 11 and 40. Right. So first see if it is in the simplified form. Then you take the denominator and get its prime factors. So here you have 8 times 5, which is 2 cube into 5. So if the denominator has only factors 2 and 5, it will terminate. So if you do the long division, you can see that this 11 by 40 can be expressed as a terminating decimal. So let us try that just to verify that if the denominator has factors 2, prime factors as 2 and 5, or 2, just 2 alone, or 5 alone, any combination of 2 and 5, then that fraction, when expressed as a decimal, will be a terminating decimal. So 11 upon 40, here 11 has to be divided by 40. Not 40 by 11 has to be divided by 40. Now 11 is less than 40, 0. Then you can continue adding zeros. You take 110. How many times? Twice. 80. 300. And 7 times. 280. 20. Again, and I add one more 0. 5 times. 200. So you can see that this is 0.275. It stops. We get a remainder 0. It's a terminating decimal. And the prime factors of 40 were 2 and 5. 2 raised to 3 and 5. That is nothing other than 2 or 5. Now, the simple fact here why it happens is you can convert it, you can supply it with more 5s or 2s and make the denominator as a power of 10. See, if I can show you here 11 upon 2 cubed into 5. Now multiply the numerator and denominator by 5 squared. Here the power of 2 is 3. What I am doing here is I am trying to make the power of 5 also as 3. So this will be 11 times 25 in the numerator, and the denominator you have 2 cube times 5 cube. So 11 times 25 is 275, and this is 2 times 5, 10 power 3, which is 1000, and hence you have 0.275. How to multiply the powers? How to simplify? Do calculations with powers of numbers. We'll be learning. You would have learnt already, or we will be doing it in a short while. We will be learning how to calculate these powers, 2 power 3 and 5 power 3. See, for example, 2 power 3 into 5 power 3 can be combined as 2 into 5 raised to 3, which is 10 raised to 3, and that would be 1000. Right. So we have seen how to convert a fraction into a decimal. Now if you have a fraction like this, 10 divided by say 7, here, or 49 or 7, here the denominator is 7. It is something different from 2 and 5. It is not 2, it is not 5, it's different from 2 and 5. So this is going to be a recurring decimal. This is for sure going to be a recurring decimal. And even another example I can give is say 17 by 18. Now look at the denominator. What are the prime factors of the denominator? You have 2 and 3. So this is 2 divided by 2 into 3 squared. Now you have a factor in the denominator 3, which is different from 2 and 5. Anything, if you have any factor in the denominator which is other than 2 or 5, it will be a recurring decimal. This will be a recurring decimal. If you do the division, 17 by 17, if you divide by 18, it will be a recurring decimal. Now I will give you the answer. I'm going to use my calculator and I'm giving you the answer. So this is 0.94 repeating, recurring decimal. So you can work out more examples like this and see when a fraction will be a recurring decimal, when will it be a terminating decimal. So only these two types are possible. A fraction can either be a recurring decimal or a terminating decimal. A decimal which is neither repeating nor neither terminating nor repeating, we have seen that it is an irrational number. You will never get such a number from a fraction. When you divide the numerator by the denominator, you will not get an irrational number. That is why these fractions are termed as rational numbers. Now let us see the other way around. How is a decimal converted into a fraction? Say 3.71. So 3.71 is a decimal. I want to convert this into a fraction. 371 divided by 100. That's all. So easy. You just count the number of digits after the decimal point and you write that particular power of the corresponding power of 10. So if I have 1.06, it is 106 divided by 100. If I have 1.006, it is 1006 divided by 1000. In the rational form, in the form P by Q.